Hello there, and welcome to Sleep Orion. Tonight, we journey back to a moment when a young nation stood at the edge of its own continent, peering into a wilderness so vast it might have been another world entirely. A wilderness where rivers carved paths through mountains older than memory, where prairies stretched beyond the curve of the earth, and where plants grew that no European eye had ever documented. This is the story of an expedition that changed not just maps, but the very understanding of what America could become. Before we begin, if you enjoy these quiet journeys through history, I invite you to like, subscribe, or share a thought in the comments. It helps others find their way here too. One curious soul at a time. For now, just breathe. Let your mind wander back through centuries. And let the whisper of history carry you to a time when discovery meant stepping into the genuine unknown. Let's begin. In the year 1803, Thomas Jefferson sat in the president's house in Washington, surrounded by books that told of lands his young nation had just acquired. Nearly 830,000 square miles of territory, purchased from France for $15 million. The Louisiana Purchase had doubled the size of the United States in a single diplomatic stroke, but the magnitude of what had been bought remained largely a mystery. Jefferson was a man of the Enlightenment, a scholar who believed that knowledge could illuminate the dark corners of the world. His library at Monticello overflowed with volumes on natural history, geography, botany, and the accounts of explorers who had ventured to the edges of the known world. He had read Captain James Cook's voyages to the Pacific, Alexander von Humboldt's descriptions of South American flora, and every fragment of information about the lands west of the Mississippi that he could acquire. The president's interest in the West predated the Louisiana Purchase by decades. Even in the 1780s, while serving as minister to France, Jefferson had met with John Ledyard in Paris, where they discussed a possible expedition to the Pacific Northwest. That dream had never materialized, but it had never died either. It had simply waited, like a seed beneath winter snow, for the proper season to emerge. Now, with vast new territories under American sovereignty, Jefferson saw an opportunity not merely for geographic exploration but for scientific discovery on a scale that might rival the great expeditions of Europe. He wanted to know what plants grew in those distant prairies and mountains. He wanted specimens collected, described, and preserved. He wanted to understand the natural resources that might support future generations of Americans venturing westward. But Jefferson's vision extended beyond mere cataloging. He understood that the botanical wealth of a territory represented potential medicines, potential crops, potential materials for construction and manufacture. Every plant that could be identified and understood was a piece of knowledge that might prove invaluable to the survival and prosperity of settlers who would one day call those lands home. The president's instructions to the expedition he would commission were explicit and detailed. They were to observe and record the soil, the climate, the animals, the peoples, and most especially the plants. They were to note which plants might prove useful for medicine, for food, for commerce. They were to collect seeds and specimens, pressing and preserving them for transport back to the centers of learning in Philadelphia and Washington. In Meriwether Lewis, Jefferson found not just a military officer but a man whose capacity for learning matched his physical courage. Lewis had served as Jefferson's personal secretary, which meant he had spent countless hours in the president's library, absorbing knowledge from the volumes that lined those shelves. Jefferson recognized in Lewis the rare combination of wilderness skills and intellectual curiosity that such an expedition would demand. But Lewis needed preparation. Scientific preparation. And so, in the spring of 1803, Jefferson sent his protégé to Philadelphia, then the intellectual capital of the young nation, home to the American Philosophical Society and some of the finest scientific minds in America. The city hummed with the energy of inquiry. Here, in elegant townhouses and meeting halls, naturalists gathered to share discoveries, to examine specimens brought from distant lands, to debate theories about the natural world. It was here that Lewis would spend intensive weeks learning the skills that would transform him from a soldier into a scientific observer. Benjamin Rush, the renowned physician who had been a signer of the Declaration of Independence, instructed Lewis in medicine and health practices. Rush was not merely concerned with treating illnesses among the expedition members, he wanted Lewis to understand how to observe and record the medicinal practices of the native peoples they would encounter, and to collect plants that might have therapeutic properties. Rush prepared for Lewis a set of questions to pose to the Indians about their health practices, their diseases, their remedies. The physician understood that indigenous peoples possessed centuries of empirical knowledge about the healing properties of plants, knowledge that had been refined through generations of careful observation. Lewis was to be not just an explorer but an ethnobotanist, documenting the relationship between people and plants across the continent. From Benjamin Smith Barton, Lewis learned the fundamentals of botany. Barton was one of America's foremost naturalists, author of Elements of Botany, the first botanical textbook published in the United States. In Barton's study, surrounded by dried plant specimens and illustrated volumes, Lewis learned the Linnaean system of classification, how to identify plants by their flowers, leaves, stems, and roots, how to describe them with precision so that other naturalists could recognize them from words alone. Barton taught Lewis how to press plants for preservation, placing fresh specimens between sheets of paper, applying pressure to flatten them, changing the papers regularly until all moisture had been removed. It was painstaking work, requiring patience and attention to detail, but it was the only way to bring the flora of the West back to the scientific community intact. The botanist also emphasized the importance of collecting seeds, which could be planted and grown, allowing living representatives of Western plants to flourish in Eastern gardens. Seeds were more durable than pressed specimens, more likely to survive the rigors of a multi-year journey through wilderness. They represented not just documentation but the possibility of transplanting Western biodiversity to Eastern soil. From Robert Patterson, Lewis learned the mathematics and techniques of celestial navigation, how to determine latitude and longitude by observing the sun, moon, and stars. Accurate geographic coordinates were essential for creating reliable maps, and those maps would be the foundation upon which future botanical surveys could be built. Every plant collected would be tied to a specific location, creating a geographic record of where each species grew. Caspar Wistar, the anatomist and physician, taught Lewis to identify and describe animal specimens, but his lessons had botanical applications as well. Understanding an ecosystem meant understanding the relationships between plants and animals, which creatures fed on which plants, how birds and insects pollinated flowers, how large herbivores shaped the landscape through their feeding patterns. Andrew Ellicott, the surveyor and astronomer, refined Lewis's skills with instruments. The expedition would carry sextants, compasses, chronometers, telescopes. These were precision devices that required careful handling and mathematical understanding. But they were also tools that would allow Lewis to create the most accurate maps of the Western territories ever produced, maps that would guide naturalists for generations to come. Throughout these intensive tutorials, Lewis absorbed not just techniques but a philosophy of observation. The scientific method demanded careful, unbiased recording of what was actually present, not what one expected or hoped to find. It required attention to detail, to the specific characteristics that distinguished one species from another. It demanded both breadth and depth, the ability to see the grand patterns of an ecosystem while also noting the particular adaptations of individual organisms. Lewis purchased supplies in Philadelphia. Books on botany and natural history that he could consult in the field. Paper for pressing plants and making notes. Waterproof containers to protect specimens from rain and river water. The tools of scientific inquiry, carefully selected and packed alongside the weapons and trade goods that would be necessary for wilderness survival. In Pittsburgh, Lewis supervised the construction of a 55-foot keelboat that would carry the expedition up the Missouri River. This vessel was more than transportation, it was a floating warehouse for all the supplies the Corps of Discovery would need, including the materials for botanical collection. Space had to be allocated for pressed plant specimens, for seed collections, for the journals in which everything would be recorded. The keelboat also carried an iron-framed boat that Lewis had designed himself, a collapsible craft that he believed could be covered with skins and used in the shallow waters of the upper Missouri. It was an engineer solution to a logistical problem, though one that would ultimately prove impractical. But the very attempt showed Lewis's innovative thinking, his willingness to improvise solutions to challenges that no American had faced before. As Lewis made his preparations, he also made the most important decision of the entire expedition. He chose William Clark as his co-commander. Clark had been Lewis's superior officer during their time in the military, a man whose skills complemented Lewis's own. Where Lewis excelled in scientific observation and writing, Clark was a master cartographer and waterman, skilled in navigation and in managing men. Clark was also experienced in dealing with Native Americans, having spent years on the frontier where diplomacy and an understanding of indigenous cultures meant the difference between survival and disaster. His presence would be invaluable when the expedition needed to trade for horses, to hire interpreters, to establish peaceful relations with tribes who controlled the territories through which they would pass. The two men shared command in practice, even though the War Department refused to grant Clark equal rank. To the Corps of Discovery and to the world, they presented themselves as co-captains, and their partnership would prove to be one of the expedition's greatest strengths. Where one man's knowledge ended, the others began. Where one man's judgment faltered, the others held firm. Together, they spent the winter of 1803 to 1800 for recruiting and training men at Camp Du Bois, near the confluence of the Mississippi and Missouri rivers. They selected unmarried soldiers who were good hunters and knew outdoor survival. Physical strength mattered, but so did adaptability, the ability to endure hardship, and a willingness to follow orders in circumstances where discipline could mean the difference between life and death. The Corps of Discovery, as Jefferson formally named them, would ultimately number more than 30 men on the permanent party, with additional boatmen and soldiers accompanying them partway up the Missouri. It was a military expedition, subject to military discipline, but it was also a scientific one, and every man would be expected to contribute to the mission of documentation and discovery. On May 14, 1804, the keelboat and two smaller pirogues pushed off from Camp Du Bois and headed up the Missouri River. The current was strong, the river broad and powerful, carrying the runoff from a vast watershed that drained half a continent. Progress was measured in miles per day, hard-won against the force of water that wanted to push them back downstream. The men poled and pulled the boats upstream, walking along the shore with tow ropes when the current proved too strong to paddle against. It was exhausting labor under a sun that beat down through cloudless skies, with insects swarming in clouds so dense they obscured vision. Mosquitoes, gnats, ticks. The men slapped and cursed, but they kept moving upstream, into territory that appeared on their maps as blank space. Even in these early weeks, Lewis began his botanical observations. The plants along the lower Missouri were largely familiar species, ones that grew in other parts of the eastern United States. But there were variations, subtle differences in size or color or the timing of flowering. Lewis noted these carefully, understanding that environmental conditions could shape how a plant expressed its form. Near present-day Kansas City, the expedition entered the Great Plains, and the landscape began to change in ways that captured Lewis's attention. The forests that had lined the riverbanks began to thin, giving way to grasslands that stretched to the horizon in every direction. The soil changed too, becoming richer, darker, deeper than anything they had seen in the east. These prairies were ecosystems unlike anything most of the expedition members had experienced. Grasses grew higher than a mounted man's head, forming a green ocean that swayed in waves before the wind. In the spring and summer, wildflowers bloomed in profusions of color, purples and yellows and whites scattered among the grasses like stars in a green sky. Lewis collected specimens of prairie flowers, pressing them carefully and recording where they had been found. He noted that certain species seemed to prefer the higher, drier ground while others clustered in the swales where moisture collected. He observed that different plants bloomed at different times, creating a succession of colors through the growing season. Among his early finds was a plant the expedition members called prairie turnip, though it would later be known by its scientific name Pediomelum esculentum, or more commonly as breadroot. The Lakota and other plains tribes harvested the starchy roots of this plant as a food source, digging them in early summer when they were most nutritious. Lewis documented not just the plant itself but its use by indigenous peoples, recognizing that this knowledge was as important as purely botanical description. The Corps encountered Native American nations with increasing frequency as they moved upstream. The Oto, the Missouri, the Omaha. Lewis and Clark held councils with tribal leaders, presenting Jefferson Peace Medals, making speeches about the new Great Father in Washington, attempting to establish diplomatic and trading relationships that would benefit American interests. But these encounters were also opportunities for ethnobotanical inquiry. Lewis asked about medicinal plants, about food sources, about which roots and berries were safe to eat and which were poisonous. The native peoples they met possessed encyclopedic knowledge of the plants in their territories, knowledge accumulated over countless generations and essential to survival on the plains. The Lakota Sioux, whom the expedition met near present-day Pierre, South Dakota, challenged the expedition with a show of force that nearly turned violent. Black Buffalo, a Lakota chief, ultimately diffused the situation, but the encounter reminded everyone that they were traveling through lands controlled by powerful nations who had their own interests and their own perspectives on the arrival of American explorers. Despite the tensions, Lewis continued his scientific work. He collected samples of sagebrush, the aromatic plant that covered vast stretches of the plains, its silvery leaves and strong scent unlike anything found in the East. Prairie sagebrush, Artemisia frigida, and several related species would become some of the characteristic plants associated with the American West. By late October of 1804, the expedition reached the villages of the Mandan and Hidatsa peoples near present-day Bismarck, North Dakota. Winter was coming fast, and these villages, located near the confluence of the Knife and Missouri rivers, would serve as the expedition's home until spring allowed them to continue westward. The Corps built Fort Mandan, a triangular stockade with quarters for the men and storage for supplies. It took nearly 4 weeks of hard labor to construct, cutting logs from the cottonwood groves along the river, raising walls, building roofs, making the structure secure against the harsh Dakota winter that was already announcing itself with freezing winds and early snows. For Lewis, the winter at Fort Mandan represented an opportunity to organize the botanical specimens and notes he had collected thus far, to prepare them for shipment back to President Jefferson in the spring. He spread out the pressed plants, reviewing them, ensuring they were properly dried and labeled. He wrote detailed descriptions in his journals, recording not just what each plant looked like but where it had been found, what soil it grew in, when it flowered, what uses the native peoples made of it. The Mandan and Hidatsa villages were centers of trade on the northern plains, places where tribes from vast distances came to exchange goods. Here, Lewis and Clark encountered traders who had traveled from as far away as the Pacific coast, and from them, they heard stories of the lands beyond the mountains, of great rivers that flowed to the Western Ocean, of forests where trees grew to unimaginable heights. It was during this winter that the expedition hired Toussaint Charbonneau, a French-Canadian trader, to serve as interpreter. Charbonneau had lived among the Hidatsa for years and spoke several native languages. More importantly, his young Shoshone wife, Sacagawea, spoke Shoshone and Hidatsa, creating a translation chain that would prove invaluable when the expedition reached the Rocky Mountains and needed to trade for horses. Sacagawea gave birth to her son Jean-Baptiste in February of 1805, while the expedition was still at Fort Mandan. The infant would travel with the corps from that point forward, becoming the youngest member of the expedition and a presence that seemed to reassure the native peoples they encountered that the expedition's intentions were peaceful. War parties did not travel with women and infants. As the days lengthened and the ice began to break up on the Missouri, Lewis prepared for the next phase of the journey. On April 7, 1805, the keelboat departed downriver, carrying boxes of specimens, journals, maps, and reports back to President Jefferson. Among those specimens were pressed plants from the Great Plains, seeds collected along the route, and detailed descriptions of the botanical findings thus far. The permanent party, now numbering 33 people including Sacagawea and her infant son, continued upstream in 6 canoes and 2 pirogues. They were leaving behind the last outposts of regular European contact. From this point forward, they would be traveling through lands where few if any white men had ventured, where the plants and animals were largely unknown to science. The Missouri River above Fort Mandan flowed through landscapes of stark beauty. White cliffs rose from the water's edge, eroded into fantastic formations by wind and weather. Cottonwood trees lined the banks, their leaves rustling in the wind like water. And everywhere, there were plants to be collected and documented. Lewis noted a species of wild flax, Linum louisi, which would eventually bear his name. The delicate blue flowers caught his attention, and he carefully collected specimens, pressing the flowers and noting that the plant grew in sandy soil along the riverbanks. Native Americans used the fibers from the stems to make cordage, another example of how indigenous knowledge transformed plants into practical tools. In mid-May, the expedition began to see the Rocky Mountains in the distance, a blue wall of peaks stretching across the western horizon. The sight was both exhilarating and daunting. Those mountains represented the greatest physical challenge the expedition would face, but they also promised botanical discoveries beyond anything found on the plains. The river began to narrow and quicken as they approached the mountains. Rapids appeared, requiring careful navigation and sometimes portage around obstacles that could smash a boat to splinters. The work was hard, made harder by the grizzly bears that wandered the riverbanks, enormous and fearless, unlike any bears the men had encountered in the east. On June 2, the expedition reached a fork in the river. The northern branch was muddy and swift, looking very much like the Missouri they had been following. The southern branch was clearer, flowing from a different direction. Which one was the true Missouri? Which one would lead them to the Continental Divide and the route to the Pacific? Lewis and Clark sent reconnaissance parties up both branches. The evidence was inconclusive, but the captain's judgment favored the southern fork. The men disagreed, believing the northern branch looked more like the Missouri. But Lewis and Clark trusted their analysis, and the expedition proceeded up the South Fork. They named the northern branch Maria's River, after Lewis's cousin Maria Wood. Days later, they heard the sound that confirmed their choice was correct. The roar of falling water echoed through the canyon ahead. The Great Falls of the Missouri, described to them by the Hidatsa at Fort Mandan, proof that they were indeed on the right river. The sight was magnificent, water plunging over a series of 5 falls, throwing up rainbows in the mist. But the falls also meant an 18-mile portage, carrying all their supplies and equipment around the falls over rough, cactus-studded ground. It took nearly a month, with men hauling crude carts loaded with gear, their feet torn and bleeding from the prickly pear cactus that covered the landscape. Rattlesnakes sunned themselves on rocks. Grizzly bears wandered close to camp. Hailstorms struck with frightening suddenness. Yet even during this grueling portage, Lewis continued his botanical work. Near the falls, he found the plant that would become forever associated with Montana and with Lewis himself. Bitterroot, Louisa rediviva, grew in the rocky soil, its small pink flowers emerging from fleshy roots that Native Americans harvested as food. The roots were indeed bitter, as the common name suggested, but they were nutritious and could be dried for storage. Lewis collected specimens of bitterroot and recorded detailed notes about its habitat and uses. He did not know then that this plant would eventually be named in his honor, becoming the state flower of Montana and a symbol of the wild beauty of the Rocky Mountain region. Beyond the falls, the river became shallower, requiring the men to wade through icy water, pulling the heavy canoes upstream against the current. The cold numbed their legs, and some men developed boils and infections from the constant immersion. But they pressed on, knowing that the source of the Missouri and the crossing of the Continental Divide lay somewhere ahead. In late July, the expedition reached the Three Forks of the Missouri, where three rivers came together. Lewis and Clark named them the Jefferson, the Madison, and the Gallatin, after the President, the Secretary of State, and the Secretary of the Treasury. They followed the Jefferson River southwest, deeper into the mountains. Sacagawea began to recognize landmarks from her childhood. She had been born somewhere in these mountains, among the Lemhi Shoshone, before being kidnapped by a Hidatsa raiding party years earlier. She pointed out Beaverhead Rock, a distinctive formation that meant they were near Shoshone territory. The expedition desperately needed to find the Shoshone, to trade for horses that would be essential for crossing the mountains. On August 12, 1805, Lewis and a small advance party crossed Lemhi Pass, standing astride the Continental Divide. They had reached the point where waters began flowing west toward the Pacific rather than east toward the Gulf of Mexico. It was a geographic milestone of immense significance. But the view from the pass shattered any hope of an easy passage to the Pacific. Instead of seeing the Columbia River flowing through a gentle valley to the ocean, Lewis saw mountains. Range after range of mountains, stretching westward to the horizon, their peaks still white with snow even in August. The most direct and practicable water communication across this continent that Jefferson had hoped to find did not exist. The reality of Western geography was far more complex and challenging than anyone in Washington had imagined. But there was also hope. Descending from the pass, Lewis encountered a band of Shoshone led by Chief Meriwether. The meeting was tense at first, warriors with bows drawn, wary of these strangers who had appeared in their territory. But Lewis used the Shoshone phrases that Sacagawea had taught him, words of friendship and peace. He presented gifts, medals, mirrors, beads. When the main party arrived days later with Sacagawea, the reunion was emotional and providential. Meriwether was Sacagawea's brother, whom she had not seen since her capture years before. The family connection helped establish trust, and Meriwether agreed to provide horses for the expedition's crossing of the Bitterroot Mountains. During the week spent with the Shoshone, Lewis continued his botanical observations. The mountain meadows were filled with flowers unlike anything found on the plains. Alpine species adapted to short growing seasons, cold temperatures, and rocky soil. Lewis collected what he could, pressing specimens carefully, noting the elevations at which different plants grew. The Shoshone shared their knowledge of mountain plants. Which roots could be eaten, which berries were safe, which plants could treat ailments. Camas roots, from the plant Camassia quamash, were a staple food, harvested in wet meadows and cooked in pit ovens. The bulbs provided carbohydrates essential for surviving in an environment where game might be scarce. Lewis noted the ponderosa pine, Pinus ponderosa, growing on the lower mountain slopes. These were massive trees, with thick bark that smelled of vanilla when warmed by the sun. The Shoshone used the seeds for food and the pitch for waterproofing. Lewis collected samples of the needles, cones, and bark, recognizing this as a valuable timber species. Higher up, he found Douglas fir, though it would not receive that common name for many years. Pseudotsuga menziesii, the scientific name would eventually become, honoring both David Douglas and Archibald Menzies, two botanists who would later study the tree. But Lewis was the first to collect and describe it for American science, noting its distinctive cones with their protruding three-point bracts. September arrived, and with it the urgency to cross the mountains before deep snow made passage impossible. The expedition left their horses with Chief Twisted Hair of the Nez Perce and set out on foot over the Lolo Trail, guided by an elderly Shoshone man called Old Toby. The Bitterroot crossing was the most harrowing experience of the entire expedition. Snow fell almost constantly, obscuring the trail. Game was scarce, and the men began to starve, reduced to eating tallow candles and portable soup, a kind of concentrated bouillon that was nearly inedible. The cold penetrated their clothing, freezing the moisture there. Men stumbled and fell on the icy slopes. Lewis had little opportunity for botanical work during those terrible days in the mountains. Survival was the only concern. But he did note that even at these elevations, clinging to rocky slopes, certain plants managed to grow. Alpine species, tough and resilient, able to endure conditions that would kill lowland plants. On September 20th, starving and exhausted, the expedition descended from the mountains onto the wheat prairie, homeland of the Nez Perce. The Nez Perce received them with kindness that likely saved the entire expedition. They fed the half-starved men, though the sudden abundance of food after weeks of near starvation made many men sick, their bodies unable to process the unfamiliar camas roots and dried fish that the Nez Perce provided. Here, on the western slopes of the Rockies, Lewis found a landscape different from anything they had encountered. The trees were enormous, towering to heights that seemed impossible. Western red cedar, western hemlock, grand fir. The forest understory was thick with ferns and mosses, everything green and damp from the frequent rains that soaked this side of the mountains. Lewis collected specimens of these massive trees, though pressing them presented challenges. A single needle cluster from some of these conifers was larger than the papers used for pressing plants. He made notes about their size, the texture of their bark, the form of their cones. He understood that these forests represented a timber resource of incalculable value. The expedition built canoes from the great trees, hollowing them out with fire and axes in the Nez Perce fashion. 5 canoes, sufficient to carry the entire party and their supplies down the rivers to the Pacific. On October 7th, they pushed off into the Clearwater River, heading downstream for the first time in more than a year. The Clearwater led to the Snake River, and the Snake led to the Columbia. They were in the drainage of the great river that flowed to the Pacific Ocean. Current helped them now instead of fighting them, carrying them swiftly westward through landscapes that continued to transform with each passing day. The Columbia River Gorge was a botanical wonderland. Here, where the river cut through the Cascade Mountains, wet coastal climates met dry inland conditions, creating zones where plants from different ecosystems grew side by side. Lewis collected Oregon grape, Mahonia aquifolium, with its hollow-like leaves and clusters of blue-black berries. Native Americans used the inner bark to make a yellow dye and the berries for food and medicine. He found salal, Gaultheria shallon, a low shrub with dark berries that the coastal tribes ate fresh or dried into cakes. He collected vine maple, sword ferns, salmonberries. Each species added to the growing catalogue of Pacific Northwest flora, plants that would eventually be cultivated in gardens around the world. On November 7, 1805, the expedition caught their first glimpse of the Pacific Ocean. Ocean in view. Oh, the joy, Clark wrote in his journal, his usually careful spelling breaking down in his excitement. They had completed the outward journey, traveling nearly 4,000 miles from the Mississippi to the Pacific. But their destination brought new challenges rather than rest. The mouth of the Columbia was storm-racked, with waves that made moving the canoes dangerous. Rain fell almost constantly, soaking everything. The men's clothes rotted from the moisture. Salt water ruined food supplies. And the coastal winter, while milder than the northern plains, was miserable in its own way. The expedition held a vote on where to spend the winter, a remarkable democratic exercise in which even York, Clark's enslaved man, and Sacagawea were allowed to participate. They chose to build a fort on the south side of the Columbia, in present-day Oregon, where game might be more abundant and where they might have a chance of encountering a trading ship that could carry letters back to the United States. Fort Clatsop, named for the local Chinook tribe, was smaller than Fort Mandan had been but built to similar design. The men cut massive logs from the surrounding forest, raised walls, built roofs, and settled in for a winter that would test them in different ways than the Northern Plains winter had. Lewis spent much of the winter at Fort Clatsop writing. He had hundreds of plant specimens to describe, notes to organize, observations to record in detail. The fort's quarters were cramped and dark, lit by tallow candles that provided barely enough light to write by. But the work was essential. These journals, these descriptions, these pressed specimens represented the scientific achievement of the expedition. He wrote about the coastal plants, so different from anything found inland. Western hemlock, Sitka spruce, shore pine. He described the massive western red cedars from which the native peoples carved their ocean-going canoes, trees that might be 10 feet in diameter and hundreds of years old. He documented the uses that the Chinook and Clatsop peoples made of various plants, the medicines, the foods, the materials. The expedition had hoped to encounter a trading ship that could carry them home by sea, but winter passed without any vessel appearing. Supplies dwindled. Elk meat, which had sustained them through the early winter, became harder to find as they depleted the local population. The men grew restless, eager to begin the return journey even though they knew it would mean another crossing of the Bitterroot Mountains. On March 23, 1806, the expedition left Fort Clatsop and began retracing their route up the Columbia River. The journey upstream was slower than the descent had been, fighting current and rapids. But spring was coming, bringing new flowers blooming along the riverbanks, and Lewis took advantage of every opportunity to collect specimens he might have missed on the way west. They reached the Nez Perce villages in May, retrieved their horses, and prepared to cross the mountains again. But snow still blocked the Lolo Trail, forcing them to wait until late June before attempting the crossing. The delay was frustrating, but it also gave Lewis time to botanize in the mountain meadows, collecting alpine flowers at the peak of their brief growing season. The return crossing of the Bitterroots was faster than the outbound journey had been, accomplished in just 6 days compared to the 11 days it had taken in September. The Nez Perce had provided guides who knew the trail, and the expedition followed them through still deep snow with confidence that had been lacking the previous autumn. On July 3, at Travelers' Rest in present-day Montana, Lewis and Clark made a fateful decision to split the expedition. They wanted to explore more territory, to map additional rivers, to maximize the geographic and scientific knowledge they could bring back from this one journey. Lewis would take a small party north to explore the Marias River and determine how far north the United States' new territories might extend. Clark would take the larger party south and east, exploring the Yellowstone River before rejoining Lewis at the confluence of the Yellowstone and Missouri. It was a risk, dividing their small force in potentially hostile territory. But it was also an opportunity to double the amount of ground they could survey. Lewis took 9 men and began his journey north, following native trails through valleys where buffalo grazed in vast herds. On July 26, near present-day Cut Bank, Montana, Lewis and his party encountered 8 Blackfeet warriors. The meeting began peacefully, with gifts exchanged and a shared camp for the night. But in the pre-dawn hours of July 27, the Blackfeet attempted to steal the expedition's guns and horses. In the brief struggle that followed, 2 Blackfeet were killed, the only violent deaths of Native Americans during the entire expedition. Lewis and his men fled, riding nearly 100 miles in a single day, expecting pursuit and retaliation that never came. They reached the Missouri River and reunited with other expedition members, then continued downstream, floating with the current that now aided their progress. The expedition reunited as planned, and by August, they were back in Mandan territory, traveling through landscapes that felt almost familiar after all they had seen beyond the mountains. They bid farewell to Sacagawea and Charbonneau, who remained at the Mandan villages. The infant Jean-Baptiste, now a year and a half old, had survived the entire journey. Clark had grown fond of the boy and offered to educate him when he was older, a promise he would later keep. Downstream from the Mandan villages, the expedition encountered trading parties coming upriver, the first American citizens they had seen in more than 2 years. These traders brought news that many in the United States had given up the expedition for lost, believing they had perished in the wilderness. The expedition members were astonished to learn they had been mourned as dead. They reached St. Louis on September 23, 1806, to a welcome that exceeded anything they had imagined. Crowds gathered on the riverfront. Cannons fired salutes. The expedition that had been given up for dead had returned, having traveled nearly 8,000 miles through lands that no American had seen before. Lewis and Clark had accomplished much of what Jefferson had asked of them. They had found no Northwest Passage, no water route across the continent, because no such route existed. But they had mapped the Missouri River to its source and found a route to the Pacific overland. They had established diplomatic contact with dozens of Native American tribes. They had brought back a wealth of scientific information about the geography, the animals, and most especially the plants of the American West. The botanical specimens alone represented a treasure of knowledge. 178 plant species new to science, or at least new to American and European science. Pressed plants, carefully preserved, showing leaf structure, flower form, and growth patterns. Seeds that could be planted and grown, introducing Western species to Eastern gardens. Detailed descriptions in the journals, telling where each plant grew, what soil it preferred, how native peoples used it. President Jefferson received the expedition's reports and specimens with delight. Here was knowledge about the lands his nation had acquired, practical information about resources and possibilities. Here was proof that American explorers could rival the great expeditions of European nations, that the young United States could contribute to the world's understanding of natural history. But the expedition's return was not the end of the story. It was the beginning of a complex process of organizing, analyzing, and publishing the knowledge they had gathered. Lewis was appointed governor of Upper Louisiana Territory, a position that brought administrative responsibilities that took him away from the scientific work he loved. Clark became superintendent of Indian affairs, using his knowledge of native peoples and his diplomatic skills to try, often unsuccessfully, to mediate between the government's expansionist policies and the rights of indigenous nations. The botanical specimens were sent to the American Philosophical Society in Philadelphia, where they were examined by leading naturalists. Some were sent to European botanists, who named the new species according to the Linnaean system, forever fixing in scientific nomenclature the discoveries of the Lewis and Clark expedition. Many species bore Lewis's or Clark's names. Louisa rediviva, the bitterroot that Lewis had found near the Great Falls. Linum louisi, the blue flax. Clarkipulchella, a delicate pink flower with fringed petals that Clark had collected in the mountain meadows. These names ensured that the memory of the expedition would be preserved not just in history books but in botanical gardens and scientific papers around the world. The impact of the expedition on American botany was profound and lasting. The plants they discovered found their way into cultivation, beautifying gardens from Virginia to England. The maps they created guided future explorers and settlers. The journals they kept provided inspiration for generations of Americans drawn westward by the promise of new lands and new discoveries. Some expedition members stayed in the West, becoming mountain men and traders. John Coulter, one of the soldiers, obtained permission to leave the expedition before it reached St. Louis, returning to the mountains to trap beaver. He would be the first white man to see the thermal features of what would become Yellowstone National Park, though his descriptions were initially dismissed as tall tales. Others returned to civilian life in the East, marrying, farming, raising families, carrying within them memories of landscapes and experiences that few of their neighbors could imagine. They had seen the Pacific Ocean, had crossed mountains that scraped the sky, had tasted plants that no European had eaten before. They had been part of something larger than themselves, a venture that changed American history. Patrick Gass, who had served as a sergeant on the expedition, published an account of the journey in 1807, beating the official narrative to mark it by years. His book, while not as scientifically detailed as Lewis's journals would be, gave American readers their first extensive look at what the Corps of Discovery had experienced and found. Lewis struggled to prepare the expedition's journals for publication. The task was enormous, requiring organization of thousands of pages of field notes, integration of botanical and zoological findings, preparation of maps, and editing of sometimes rough and repetitive daily entries into a coherent narrative. The weight of it, combined with his duties as territorial governor and what may have been depression and alcoholism, overwhelmed him. In October of 1809, while traveling on the Natchez Trace in Tennessee, Meriwether Lewis died of gunshot wounds at a remote inn called Grinder's Stand. Whether his death was suicide or murder remains a matter of historical debate, but the loss to American science was undeniable. He was only 35 years old. Clark took on the responsibility of seeing the expedition journals published, but he lacked Lewis's scientific expertise. He eventually turned to Nicholas Biddle, a Philadelphia lawyer and editor, to prepare the narrative. Biddle's edition, published in 1814, told the story of the expedition but omitted much of the scientific detail that Lewis had so carefully recorded. The complete journals, with all their botanical observations and specimen descriptions, would not be published until 1893, when Elliott Coues produced an annotated edition. Even then, the full scope of Lewis's botanical work remained somewhat obscure, overshadowed by the adventure narrative of the expedition itself. But the plants remained. In herbarium collections, in botanical gardens, in scientific names that had been assigned to new species. They remained as evidence of Lewis's careful observations, his dedication to documenting the natural world even under circumstances of extreme hardship and danger. The expedition had demonstrated that botanical exploration required not just scientific training but also physical courage, diplomatic skills, and the ability to learn from indigenous peoples who understood their environments in ways that no European visitor could immediately grasp. The plants Lewis collected were not growing in isolation, they were parts of ecosystems that had been shaped by human use for thousands of years. Native Americans had domesticated certain plant species, selecting for desirable traits over generations of cultivation. They had learned which plants were edible, which were medicinal, which provided materials for tools and clothing. This knowledge was empirical science, accumulated through observation and experimentation, transmitted through oral tradition and practical teaching. When Lewis recorded that information in his journals, he was bridging two systems of knowledge. European botanical classification met indigenous ethnobotany, creating a more complete understanding of how plants fitted into both natural and human landscapes. The expedition's discoveries would influence American expansion and the settlement of the West. Plants that Lewis had documented as food sources for native peoples became crops for white settlers. Timber species that he had noted became the basis for logging industries. Grazing lands covered with the grasses he had described became ranches and farms. Not all of these transformations were positive. The vast buffalo herds that had sustained the plains tribes were hunted nearly to extinction. The prairies that Lewis had seen stretching endlessly were plowed under and planted with European crops. The forests where trees grew to incredible heights were clear-cut, and the massive logs were shipped to lumber mills. But the botanical knowledge remained valuable beyond its economic applications. The plants themselves, growing in nature reserves and botanical gardens, reminded people of what the American West had looked like before industrialization and intensive settlement. They represented a biological heritage, a genetic diversity that might prove important in ways that could not yet be imagined. As the 19th century progressed, other expeditions ventured into the American West. Some followed routes that Lewis and Clark had pioneered. Others explored regions that the Corps of Discovery had not reached. But all of them built on the foundation that Lewis and Clark had established, the understanding that the West was not empty wilderness but a complex mosaic of ecosystems, each with its own characteristic plants, animals, and human inhabitants. Botanists like Thomas Nuttall and John Toy examined the specimens that Lewis had collected, describing new species and working to fit Western plants into the growing edifice of botanical classification. David Douglas, a Scottish botanist, traveled to the Pacific Northwest in the 1820s and 20s, collecting plants and sending seeds back to England, where many became popular ornamental species. The Douglas fir that bears his name had first been documented by Lewis, but Douglas's subsequent work made the tree familiar to botanists and gardeners around the world. Asa Gray, one of America's foremost 19th-century botanists, studied the relationships between North American and Asian plant species, recognizing that many genera had representatives on both continents. This biogeographical work built on Lewis's observations about the distribution of Western plants, helping to establish ecology as a scientific discipline that sought to understand how organisms related to their environments. The expedition's legacy lived on not just in individual plant species but in the very idea that scientific exploration was a worthwhile national endeavor. Jefferson's support for the Corps of Discovery established a precedent for government funding of scientific research, a tradition that would eventually lead to the creation of federal agencies devoted to natural resource management and scientific inquiry. The United States Geological Survey, the Bureau of Reclamation, the National Park Service. All of these institutions had roots in the idea that understanding the natural resources of the nation was essential for wise stewardship and sustainable use. Lewis and Clark's careful documentation of what they found in the West provided a baseline against which future changes could be measured. In the 20th century, as environmental conservation became an increasingly important concern, the expedition's journals took on new significance. They described ecosystems that had been altered or destroyed by development, offering glimpses of what had been lost and what might potentially be restored. The grizzly bears that Lewis had described as so numerous became endangered species, surviving only in protected areas. The prairie grasslands that had sustained enormous buffalo herds became agricultural lands, with only remnant patches preserved in nature reserves. Plant species that Lewis had collected from abundant populations became rare, their habitats fragmented or eliminated by human development. But the seeds and specimens that had been carefully preserved offered the possibility of reintroduction and restoration. Bitterroot could be propagated from seeds descended from the plants Lewis had found. Wild flax could be re-established in native prairie restorations. The journals themselves became important historical documents, studied not just for their scientific content but for what they revealed about cross-cultural encounters, about the Native American nations that Lewis and Clark had met, about environmental conditions before intensive European American settlement. Every entry, every plant description, every note about where something grew became a piece of evidence about what the American West had looked like at a particular moment in time. Modern scholars return to Lewis's botanical descriptions, comparing them with current conditions to understand how ecosystems had changed over 2 centuries. Climate change, invasive species, land use alterations. All of these factors had transformed Western landscapes in ways both subtle and dramatic. Lewis's observations provided a window into a past that could help inform decisions about the future. The Corps of Discovery had embarked on their journey with portable desks and leather-bound journals, with paper for pressing plants and containers for collecting seeds. They had carried these materials across the continent and back, protecting them through storms and portages, through winter camps and mountain crossings. The determination to preserve that scientific record, even when carrying a few more pounds seemed unbearable, reflected a commitment to knowledge that transcended personal comfort. That commitment had been Jefferson's gift to the expedition, the understanding that they were not merely scouts finding a route but scientists documenting a world. Lewis's training in Philadelphia had prepared him to see plants not just as objects but as members of species with particular characteristics, adapted to specific environments, potentially useful for particular purposes. Clark's skills as a cartographer meant that every plant collection could be tied to a specific location, creating a geographic record of where species grew. The maps he drew, showing rivers and mountains and Native American villages, also showed the distribution of natural resources, including the plants that Lewis had so carefully collected. Together, the two men created a comprehensive record of their journey that combined narrative, science, geography, and cultural observation. It was a holistic approach to exploration, recognizing that understanding a place required attention to all aspects of its natural and human systems. The expedition members who were not trained scientists also contributed to this effort. Sergeants kept journals, recording daily events and observations. The men helped collect specimens, assisted with portages and camp duties that freed Lewis and Clark for their scientific work. Even York and Sacagawea, who occupied subordinate positions in the expedition's hierarchy, contributed knowledge and skills essential to success. York's strength and hunting ability helped keep the expedition fed. His presence, as the first African American many Western tribes had seen, sparked curiosity and discussion that sometimes facilitated diplomatic encounters. Though enslaved and unable to claim any reward for his service, York was nevertheless an integral part of the core of discovery. Sacagawea's knowledge of Shoshone language and territory proved invaluable at crucial moments. Her ability to identify edible roots and berries supplemented the expedition's diet. Her presence with an infant reassured tribal peoples that the expedition came in peace. And her emotional reunion with her brother Kamiwate created a family connection that led to the expedition obtaining the horses they desperately needed. The plant knowledge of native peoples, passed to Lewis through interpreters, enriched his botanical documentation immeasurably. Without that knowledge, he would have been able to describe what plants looked like, but not how they were used, not what role they played in human subsistence and culture. The ethnobotanical information he recorded preserved knowledge that would otherwise have been lost as traditional Native American ways of life were disrupted by American expansion. Some of that knowledge proved immediately practical. When expedition members fell ill, native remedies sometimes proved more effective than the medicines Lewis had brought from Philadelphia. When food ran short, knowing which roots and berries were edible made the difference between hunger and starvation. Other knowledge had longer-term value. Understanding that certain plants had medicinal properties led to their later study by pharmacologists. Recognizing that native peoples had been managing landscapes through controlled burning and selective harvesting changed ideas about wilderness as something pristine and untouched by human influence. The expedition returned to an America that was already beginning to change in profound ways. The Louisiana Purchase had doubled the nation's size, opening vast territories for settlement and exploitation. As the years passed, that expansion would come at tremendous cost to the native peoples whose lands were taken, whose ways of life were disrupted, whose populations were decimated by disease and warfare. Lewis and Clark had initiated contact that would lead to consequences they could not have foreseen. The maps they drew guided settlers and soldiers. The reports they made of abundant resources encouraged exploitation. The diplomatic contacts they established were often followed by broken treaties and forced relocations. It is impossible to untangle the expedition's scientific achievements from its role in American imperialism. The same journals that documented plant species also asserted American sovereignty over lands that indigenous peoples had occupied for millennia. The same skills that allowed Lewis to identify and describe new botanical specimens also served military and commercial interests seeking to exploit Western resources. This complicated legacy requires acknowledgement. The expedition's contributions to botany and natural history were genuine and valuable. But they were made in service of a national expansion that brought suffering to many. Both truths must be held simultaneously, neither erasing the other. In our own time, Lewis and Clark's botanical work takes on new relevance as we face environmental challenges they could not have imagined. Climate change is altering the habitats where the plants they documented grow. Invasive species are displacing native ones. Development continues to fragment and destroy ecosystems. The baseline data that Lewis provided becomes ever more precious as a record of what once was and what might be restored. Conservation efforts now use Lewis's descriptions to guide restoration of native plant communities. Seeds descended from plants he collected are propagated and reintroduced to habitats where they had been lost. The species names that bear his honor: Louisia, Linum louisi, Clarkia. They remind us that understanding and valuing the natural world requires both scientific rigor and personal connection. Lewis saw those flowers blooming in mountain meadows and by great waterfalls. He knelt in the dirt to dig up roots and examine their structure. He felt the texture of leaves, noted the fragrance of sagebrush, tasted the bitter roots that native peoples gathered for food. His observations were not just intellectual exercises but sensory experiences, encounters with living things in particular places at particular moments. That dimension of botanical exploration, the intimate encounter with individual organisms in their native habitats, gives the science a human face. Behind every specimen in a herbarium collection, behind every entry in a field journal, there is a person who stopped, looked carefully, and tried to understand what they were seeing. For Lewis, that process happened against a backdrop of enormous physical and logistical challenges. Botanical work was not his only responsibility or even his primary one. He was co-leading an expedition of military discipline through potentially hostile territory, trying to establish diplomatic relations with powerful Indian nations, mapping rivers and mountains, hunting for food, dealing with illness and injury and the constant threat of disaster. That he managed to collect and preserve 178 plant species under such circumstances is testimony to his commitment to the scientific mission Jefferson had given him. It speaks to a dedication that persisted even when he was exhausted, cold, hungry, or in danger. The pressed flowers he sent back to Philadelphia were earned through hardship we can barely imagine. In the years since the expedition, those pressed flowers and the descriptions that accompanied them have been studied, cited, and celebrated by generations of botanists. They appear in floras and field guides, in botanical monographs and ecological studies. They live on in the gardens where bitterroot and blue flax and clarkia grow far from their native western habitats, shared with people who will never see the Rocky Mountains but can appreciate the beauty of their wildflowers. The expedition's journey, from the Mississippi to the Pacific and back again, traced a path across a continent that would soon be transformed by the very knowledge they had gathered. Roads would follow the routes they had pioneered. Towns would spring up along rivers they had mapped. Farms would be established in valleys they had described. The wilderness they had explored would become, within a few generations, a settled and developed region. But something of what they saw and documented remains. In national parks and wilderness areas, in botanical gardens and herbarium collections, in the journals that recorded not just what they found but how it made them feel. Lewis's writing, especially, conveys a sense of wonder at the landscapes and organisms he encountered, a recognition that he was seeing things that no one of his background had seen before. That sense of wonder, more than any individual plant specimen, may be the expedition's most important legacy. It reminds us that the natural world is full of marvels, that careful observation reveals complexity and beauty, that taking time to understand other forms of life enriches our own existence. In an age of environmental crisis, when many people feel disconnected from nature, the expedition's example offers something valuable. Lewis and Clark and their companions traveled slowly through landscapes, taking time to observe and record what they saw. They paid attention to details, to the specific characteristics of individual plants and animals, to the ways different species interacted with their environments. They learned from people who had accumulated knowledge over countless generations, acknowledging that understanding comes from multiple sources and perspectives. These practices: slow observation, attention to detail, learning from diverse sources. They are as relevant now as they were 2 centuries ago. Perhaps more so, as we grapple with environmental changes happening at scales and speeds that challenge our ability to comprehend them. The plants that Lewis collected still grow, most of them, in the places where he found them. Bitterroot still blooms in rocky mountain soil. Blue flax still colors prairie hillsides. Douglas fir still towers in Pacific Northwest forests. They are living links to that moment when the core of discovery passed through, when one curious mind took the time to stop and truly see them. To stand in those places now, to see those plants still thriving, is to feel a connection across time. Lewis walked here. He saw this view. He bent down to examine this flower, felt its petals, counted its stamens, recorded its color in his journal by candlelight that evening. The plants endure. The landscapes, though changed, retain echoes of what they were. The knowledge he gathered continues to resonate. As we close this first part of our journey through the botanical discoveries of the Lewis and Clark expedition, we leave Lewis and Clark back in St. Louis, their outward journey complete, their specimens and journals beginning the process of being shared with the scientific community. But their story is only half told. In Part 2, we will follow the expedition's botanical legacy forward through the 19th and 20th centuries, exploring how the plants they collected influenced American botany, how their observations contributed to the scientific understanding of Western ecosystems, and how their work continues to matter in our own time. We will see how seeds they gathered grew into gardens half a world away, how species they documented faced threats they could not have imagined, and how their journals became resources for conservation efforts trying to restore what has been lost. Until then, rest well, and let the image of mountain meadows filled with flowers accompany your dreams. Tomorrow's discoveries await. The boxes that left St. Louis in the autumn of 1806 contained more than pressed plants and journals. They contained evidence of a world that most Americans had never imagined. Within those carefully packed specimens lay the proof that the Western Territories were not a wasteland but a botanical treasure house, rich with species adapted to environments ranging from dry prairies to mountain peaks to rain-soaked coastal forests. Each box had been prepared with meticulous care during those final weeks in St. Louis. Lewis and Clark sorting through materials that had traveled thousands of miles, selecting what should be sent east for study. The pressed plants had accumulated through more than 2 years of travel, collected at different seasons, from different elevations, in different climate zones. Some had been pressed immediately after collection, in the field, between papers that Lewis carried for that purpose. Others had been gathered and preserved later when time permitted more careful preparation. The quality of preservation varied. Some specimens were crisp and intact, their leaves and flowers flattened but recognizable, colors faded but structures preserved. Others were fragmentary, damaged by the rigors of travel, by moisture that had penetrated their wrappings, by the wear that came from being transported in canoes through rapids and on horseback over mountain trails. But even the damaged specimens retained value. A broken stem could still show leaf arrangement. A flower missing petals might preserve the structure of its seed head. A root system fragmentary from rough handling could still indicate the plant's mode of growth. Lewis had learned from Benjamin Smith Barton that imperfect specimens were better than no specimens, that botanical science could work with whatever materials survived the field, extracting information through careful examination even when preservation was less than ideal. The journey of those boxes to Philadelphia was itself an undertaking of some complexity and risk, another chapter in the story of how these botanical materials came to serve science. Thomas Jefferson, keenly aware of how much depended on the specimens reaching Philadelphia safely, had arranged for multiple shipments by different routes. He understood that river transport, while often the most practical way to move goods across long distances in early 19th century America, carried risks. Boats sank in storms or ran aground on sandbars. Cargoes could be damaged by water intrusion or lost entirely if vessels capsized. Overland transport avoided those particular dangers but introduced others. Wagons traveling rough roads jolted over ruts and stones, subjecting their cargoes to impacts that could shatter delicate items. The roads themselves were primitive by modern standards, barely more than tracks through forests in many areas, muddy quagmires during wet seasons, dusty and rutted during dry spells. Bridges were scarce. Rivers had to be forded, which meant getting wagons and their contents wet. There were no hotels along most routes, so teamsters camped beside the road, and cargo sat exposed to weather unless protected by tarps that often leaked. Some boxes traveled by boat down the Mississippi River to New Orleans. This was the major transportation artery linking the interior of the continent to the Gulf Coast and the Atlantic seaboard. Flatboats and keelboats moved goods downriver, taking advantage of the current. The journey from St. Louis to New Orleans might take several weeks, depending on water conditions and how often boats stopped at settlements along the way to load or unload cargo. In New Orleans, the boxes would be transferred to ocean-going ships for the voyage around the Florida Peninsula and up the Atlantic coast to Philadelphia. This leg of the journey took them through the Gulf of Mexico, around the Florida Keys, and into open Atlantic waters. Storms were always a danger. Ships could founder, could be driven onto reefs or shoals, could be damaged by wind and wave until they took on water and sank. Pirates operated in the Caribbean and sometimes harassed vessels in coastal waters. The passage from New Orleans to Philadelphia might take 2 to 4 weeks if conditions were favorable, longer if weather was bad or if the ship made multiple stops at ports along the way. Other boxes traveled overland, packed on wagons that followed post roads and primitive highways eastward. The route might go through Louisville and over the Appalachian Mountains through Cumberland Gap, then across Virginia to the Potomac River and down to Washington or Baltimore, from which onward transport to Philadelphia could be arranged. Or boxes might travel northeast more directly, crossing Indiana and Ohio to Pittsburgh, then following roads through Pennsylvania to Philadelphia. Each route had advantages and disadvantages, and the choice depended on what transport was available at a given time, what the condition of roads was, where reliable freight agents could be found. Jefferson had arranged for trusted agents to oversee the transfers and shipments, men who understood the value of what they were handling and who could be relied upon to treat the boxes carefully. But even with good agents, things could go wrong. A wagon wheel might break, forcing cargo to be transferred to another vehicle with potential for damage during the process. A shipment might sit on a dock too long, exposed to rain before being loaded. A warehouse fire could consume goods awaiting transfer. The logistics of moving materials across early 19th century America were challenging, uncertain, fraught with possibilities for loss or damage. But Jefferson persisted, sending multiple shipments to increase the odds that at least some would arrive safely. And his care paid off. Through autumn and winter of 1806 and into the spring of 1807, boxes arrived in Philadelphia. Some came by ship, unloaded on the Delaware River wharves where merchants received tobacco from Virginia and rice from Carolina. Others came by wagon, delivered to Jefferson's residence on occasions when he was in Philadelphia, or to the headquarters of the American Philosophical Society directly. Each arrival was an event, a moment of anticipation and relief. Wooden crates were opened carefully, their contents examined to assess condition. How much moisture had penetrated? Were the specimens still recognizable? Had labels remained attached, or had they become separated from the plants they were meant to identify? Sometimes the news was good, materials arriving in remarkably good condition considering what they had endured. Sometimes it was less encouraging, specimens water-stained or partially decayed, though usually still salvageable with care. The American Philosophical Society, where most materials were eventually deposited, became the center of all subsequent work with Lewis and Clark's botanical discoveries. Founded by Benjamin Franklin in 1743, the Society embodied Enlightenment ideals about the progress of knowledge through observation, experimentation, and rational inquiry. Its members represented the intellectual elite of American society, men who combined professional careers in law, medicine, or commerce with serious avocations in natural philosophy, as science was then called. The Society's headquarters on 5th Street in Philadelphia, between Chestnut and Walnut Streets, contained a library where members could consult scientific publications from America and Europe, collections of minerals and fossils and ethnographic objects brought back from explorations, scientific instruments for astronomical and meteorological observations, and meeting rooms where members gathered to present papers and discuss the latest developments in various fields of knowledge. It was, in essence, America's first research institution, a place dedicated to advancing human understanding of the natural world and sharing that understanding among scholars. The arrival of the Lewis and Clark materials created considerable excitement among the Society's members. Here were plants from regions that no trained botanist had ever visited. Here were detailed descriptions recorded under field conditions by an observer who had been specifically trained for the task. Here was an opportunity to expand American botany's understanding of the continent's flora in a single dramatic leap. Benjamin Smith Barton, who had trained Lewis in botanical observation methods before the expedition departed, was among the first to examine the specimens when they arrived in Philadelphia. For Barton, this was a moment of validation and excitement. He had spent several weeks with Lewis in the spring of 1803, teaching him how to press plants properly, how to record essential information about each specimen, how to recognize characteristics that distinguished one species from another. He had provided Lewis with plant presses, papers for drying specimens, and detailed instructions about what information should be recorded for each collection. Now, more than 3 years later, Barton could see the fruits of that training. Lewis had followed the methods taught to him with remarkable consistency. The specimens, despite their age and the conditions under which they had been collected and transported, were generally well prepared. Most had been pressed flat while still fresh, which preserved their forms better than if they had been allowed to wilt before pressing. Many retained enough structural detail that Barton could examine flower parts, count stamens and pistils, observe leaf venation patterns, identify fruit structures. The labels that accompanied most specimens included location information, dates of collection, and sometimes habitat notes, all essential for understanding the ecological context in which plants grew. Barton spread specimens out on tables in his study, examining them by daylight that came through tall windows, sometimes bringing an oil lamp close when he needed to see fine details. He had spent his career studying American plants, building one of the most extensive knowledge bases of any botanist in the United States about the flora of the eastern states. But his knowledge of Western plants was necessarily limited. A few specimens had made their way east from fur traders or from Spanish territories, enough to suggest that the West harbored botanical diversity, but not enough to provide comprehensive understanding. Now, with Lewis's collection before him, patterns began to emerge. Some plants clearly belonged to genera he knew well from eastern North America. A sunflower that resembled Helianthus species from Pennsylvania but had narrower leaves and smaller flower heads, suggesting it was adapted to drier conditions. A mint with the family's characteristic square stems and aromatic foliage but with flower structures different from any mentha or monarda he had seen, indicating a new species and possibly a new genus. a willow that had the growth form and leaf shape typical of Salix but details of its catkins that marked it as distinct from eastern willows. These finds excited him because they suggested what plant geographers of the time were beginning to suspect: that the flora of North America included many pairs or groups of related species, some in the east and others in the west, similar enough to recognize kinship but distinct enough to warrant recognition as separate species. This pattern implied evolutionary relationships, though the mechanisms by which such relationships developed would not be understood until Charles Darwin's work half a century later. But even without evolutionary theory, botanists could recognize that similar plants occurring in different regions suggested common ancestry and divergence shaped by adaptation to different environments. Other plants in Lewis's collection were more puzzling. They seemed to fit no genus Barton knew. Their combinations of characteristics, the ways their flowers were structured, the patterns of their leaf arrangement, the forms of their fruits and seeds, suggested relationships to known plant families but required new generic categories to accommodate them. These were the finds that excited Barton most because they represented not just new species but new branches on the tree of plant taxonomy, gaps in botanical knowledge that Lewis's collections now filled. Barton recognized immediately that describing this material properly would require years of dedicated effort. Each species needed a detailed written description in Latin, the international language of botanical science. The description had to specify all the characteristics that defined the species, the size and shape of leaves, the number and arrangement of flower parts, the structure of fruits and seeds, the overall growth form of the plant. These descriptions had to be precise enough that another botanist, reading them years or decades later, could recognize the same species if they encountered it. Each new species also needed comparison with related species to demonstrate why it deserved recognition as distinct rather than being lumped with existing species as a variety or subspecies. This required access to herbarium collections where specimens of related plants were housed, to published floras that described species from other regions, to the accumulated knowledge of botanical taxonomy. Barton had good resources at his disposal: the American Philosophical Society's library and his own extensive personal collection of books and specimens, but even so, the work was daunting. And each species needed placement within the broader classification system that organized botanical knowledge. The Linnaean system of binomial nomenclature, developed by Swedish botanist Carl Linnaeus in the 18th century, had become the standard framework for naming and organizing plants. Each species received a two-part name, the first part identifying its genus, the second part distinguishing it from other species in that genus. But deciding which genus a plant belonged to required understanding family characteristics, recognizing patterns in how different genera related to each other, sometimes making judgments about whether a plant fit better in an existing genus or required a new one. This was work that demanded not just botanical expertise but judgment, experience, and access to comprehensive reference materials. Barton had the expertise. He had spent decades studying plants, building his knowledge systematically. But he was also a busy man with multiple commitments that competed for his time and attention. He held a professorship in natural history and botany at the University of Pennsylvania, where he taught medical students who needed to understand medicinal plants. He served on the faculty of the College of Physicians, contributing to medical education and public health initiatives. He maintained a private medical practice, seeing patients who sought his expertise in diseases and treatments. He was also actively conducting his own botanical research, making collecting trips into regions of Pennsylvania, New Jersey, and Delaware that he had not previously explored. He studied the medicinal uses of plants, particularly those used by Native American peoples, believing that indigenous knowledge could guide the discovery of valuable therapeutic agents. He wrote papers on various scientific topics for presentation to the American Philosophical Society and for publication in scientific journals. He corresponded with other naturalists, both in America and in Europe, exchanging information and specimens, building the networks of collaboration essential for advancing scientific knowledge. His time, in short, was fragmented, divided among many worthy pursuits. The Lewis and Clark plant collection, despite its obvious importance and scientific value, became one project among many. Barton would work on it when he could, setting it aside when other demands pressed more urgently. He intended to complete a comprehensive treatment of the botanical discoveries, a major publication that would establish these Western plants firmly in the scientific literature and bring credit to American science. But the work progressed slowly, more slowly than Barton liked but as quickly as his circumstances allowed. Months passed, stretching into years. Barton completed descriptions for some species, got them published in scientific papers or included them in manuscripts he was preparing. But the bulk of the collection remained unprocessed, specimens sitting in his study awaiting the attention he could not give them as fully as he wished. Other events complicated the situation further. Political tensions between the United States and Britain escalated in the years following the expedition's return, eventually erupting into the War of 1812. The conflict disrupted transatlantic scientific communication, making it difficult to obtain botanical publications from England or to send specimens to European botanists for comparison with plants in their collections. Barton's own health, never robust, declined during this period. He suffered from respiratory problems that worsened in Philadelphia's damp winters. He experienced episodes of debilitating illness that forced him to suspend all work for weeks at a time. His energy, when he had it, had to be rationed carefully among his various commitments. The botanical work he loved often had to yield to medical responsibilities that paid his bills and supported his family. And then came a personal tragedy that affected him deeply. Meriwether Lewis died in October of 1809, only 3 years after returning from the expedition. The circumstances were disputed then and remain controversial now, whether Lewis took his own life or was murdered. But for Barton, the loss was profound. Lewis had been his student, someone he had trained and sent west with confidence that the training would be put to good use. The expedition's botanical achievements had validated Barton's teaching methods, demonstrated that proper instruction could enable a non-specialist to make valuable scientific collections. Lewis's death also removed a valuable resource. Barton had hoped to consult with Lewis about the specimens, to ask where particular plants had been found, what habitats they occupied, what Native American names or uses they had. Lewis's field notes and journal entries provided some of this information, but not all. Memory held details that had not been written down, observations that seemed unimportant in the field but that might have mattered for botanical identification or classification. With Lewis gone, those memories were lost, questions Barton might have asked would never be answered. Into this difficult situation stepped Frederick Persch, a German botanist who had immigrated to America in 1799, seeking opportunities not available to him in Europe. Persch was born in Saxony in 1774, trained in horticulture and botany, and had worked in various botanical gardens before deciding to try his fortune in the New World. America in the late 18th century offered prospects for ambitious young men willing to work hard and adapt to frontier conditions. The young nation was expanding, exploring its vast territories, eager to understand and utilize natural resources. Botanists who could identify useful plants, who could establish gardens and nurseries, who could collect specimens for institutions and wealthy patrons, found opportunities for employment and advancement. Persch had worked as a botanical manager for William Hamilton, whose private gardens at the woodlands near Philadelphia contained one of the finest plant collections in America. Hamilton was a wealthy merchant with a passion for horticulture who had assembled thousands of species from around the world. The woodlands featured ornamental plantings, experimental gardens where newly introduced plants were tested for hardiness and cultural requirements, and greenhouse collections of tropical and subtropical species. Managing such an establishment required extensive botanical knowledge, practical horticultural skill, and administrative ability. Persh had demonstrated all three, earning Hamilton's confidence and gaining valuable experience. The position at the Woodlands gave Persh access to living plants from many regions, allowing him to observe growth habits, flowering patterns, and other characteristics that herbarium specimens alone could not reveal. He learned to recognize subtle differences between similar species, to understand how environmental conditions affected plant form and vigor, to propagate plants from seeds and cuttings. This practical experience complemented the theoretical knowledge he had gained through formal botanical training. Persh had also traveled widely in eastern North America, making collecting trips from Maryland to New Hampshire, venturing into the Appalachian Mountains, exploring coastal regions and river valleys. These expeditions built his knowledge of American native plants, familiarizing him with species that occurred in different habitats and regions. He pressed specimens from his travels, built his own personal herbarium as a reference collection, and developed a mental catalogue of North American flora that was among the most comprehensive of any botanist working in America at the time. In 1805, Benjamin Smith Barton hired Persh to work on a proposed flora of North America, a comprehensive reference work that would describe all the continent's known plant species. This was an enormously ambitious project, reflecting Barton's vision of establishing American botany as a field equal to European botanical science. A North American flora would be a landmark achievement, a book that scientists everywhere would need to consult, a demonstration that the New World's natural riches were being systematically documented and studied. Persh's role was to sort through vast amounts of material, identify specimens, write preliminary descriptions, and organize everything into a usable format. Barton would oversee the project, provide final review of identifications and descriptions, and handle publication arrangements. It was exactly the kind of large-scale systematic work that suited Persh's talents and interests, and he threw himself into it with characteristic energy and dedication. Persh named numerous species based on Lewis's collections. Louisa rediviva, the bitterroot, honored Lewis directly in its genus name. Linum louisi, the wild blue flax, carried his name as a specific epithet. Other plants received names that reflected their characteristics or the places where they had been found, but in the descriptions, Persh acknowledged that Lewis had been the first to collect and document them. Some specimens made their way to Europe, where botanists like Aylmer Burke Lambert in London examined them and published descriptions in European scientific journals. This transatlantic exchange of information was essential for botanical science in the early 19th century, when communications were slow, but scientists recognized that understanding plant geography required collaboration across borders and oceans. The seeds that Lewis had collected were planted in gardens, some in Philadelphia, some in Washington at Monticello, where Jefferson could watch Western plants grow in Virginia soil. Not all germinated, after years in storage and after being carried thousands of miles in conditions that were far from ideal. But some did, and they represented living connections to the landscapes Lewis had explored. Bitterroot seeds sprouted and grew, producing their distinctive pink flowers in eastern gardens. The plants were curiosities, conversation pieces, proof that the Western territories contained botanical marvels. But they were also scientific resources, living specimens that botanists could observe over multiple growing seasons, watching how they responded to different conditions than those in their native habitats. Jefferson took particular delight in the plant specimens and seeds. At Monticello, he cultivated Missouri corn that Lewis had sent back, finding it grew well in Virginia's climate and produced good yields. He planted other Western species in his garden plots, experimental plantings that combined his scientific curiosity with his practical interest in agriculture. For Jefferson, understanding Western botany was not merely an academic exercise but a way of assessing what the new territories might offer to American farmers and settlers. The president's vision had always extended beyond mere discovery. He wanted the West to be knowable, mappable, usable. He wanted its resources identified and, where possible, exploited for the benefit of the growing nation. The botanical collections provided exactly that kind of practical intelligence, showing what plants grew where, what might be cultivated, what timber resources existed, what grazing lands might support livestock. But there was also something more in Jefferson's response to the expedition's botanical achievements. There was pride that American explorers had contributed to scientific knowledge, that the young nation was not merely a cultural backwater dependent on European expertise but a place where original research and discovery could occur. The plants Lewis had collected announced to the world that America had its own natural wonders, worthy of study and appreciation. The maps that Clark had drawn, with their notations about where particular plants grew, became tools for future explorers and scientists. Botanists planning expeditions to the west could use those maps to identify promising locations for plant collecting. They could trace the paths Lewis and Clark had followed, or they could venture into regions the Corps of Discovery had not reached, using the expedition's findings as a baseline for comparison. Throughout the 1810s and 20s, other naturalists began making their own journeys to the west. Thomas Nuttall, an English botanist working in America, traveled up the Missouri River in 1811, collecting plants and making observations that complemented Lewis's work. Nuttall would eventually cross the continent to the Pacific, though by a more southern route than Lewis and Clark had taken, documenting the flora of regions they had not visited. Nuttall's collections, combined with Lewis's, began to reveal patterns in how plants were distributed across the continent. Certain species ranged from the Mississippi to the Pacific. Others were restricted to particular mountain ranges or river valleys. Still others seemed to prefer specific elevations or soil types. These patterns hinted at the environmental factors that shaped plant communities, the relationships between climate, geography, and biodiversity. John Bradbury, another English botanist, accompanied fur trading expeditions up the Missouri in the early 1800s. His travels took him through some of the same territory Lewis and Clark had explored, and he collected extensively, sending specimens back to England and publishing accounts of his botanical findings. Bradbury's work built on the foundation Lewis had established, adding new species to the growing catalogue of Western flora. Edwin James, who served as botanist on the Stephen Long expedition of 1819 and 20, explored the Central Plains and the Rocky Mountains, collecting plants and making observations about their ecology. James was the first white man to climb the peak that would later be named Pikes Peak, and he documented the alpine flora he encountered at high elevations, species adapted to harsh conditions and short growing seasons. These subsequent expeditions validated much of what Lewis had reported while also expanding knowledge into new areas. They confirmed that the West was indeed rich in plant diversity, that different regions had distinctive flora shaped by their particular environmental conditions. They also revealed that much work remained to be done, that vast areas had not been botanically surveyed, that new species likely remained undiscovered. David Douglas, perhaps the most successful plant collector of the early 19th century, made multiple expeditions to the Pacific Northwest in the 1820s. A Scottish botanist working for the Horticultural Society of London, Douglas collected seeds of hundreds of species and sent them back to England, where they were cultivated in gardens and estates. Many became popular ornamental plants, spreading from England to Europe and eventually back across the Atlantic to American gardens. The Douglas fir, named in his honor, became one of the most economically important timber trees in the world. But Lewis had been the first to document it, collecting specimens near the Pacific coast during the expedition's winter at Fort Clatsop. Douglas's later work brought the tree to broader attention and made its seeds widely available for planting, but Lewis deserves credit for the initial discovery. This pattern would repeat with many Western plants. Lewis made the first scientific collection, but later botanists who had more time to focus solely on natural history, who were not simultaneously leading a military expedition through dangerous territory, were able to collect more extensively and to publicize their findings more effectively. Lewis's achievements were foundational, but they were also starting points for work that others would continue. Throughout the 19th century, as more expeditions ventured west and as settlers began occupying the territories Lewis and Clark had explored, botanical knowledge of the region grew exponentially. Railroad surveys in the 1850s employed botanists to document plants along proposed routes. Military expeditions to subdue Indian tribes included scientists who collected specimens even as they participated in conquest. Government surveys under Ferdinand Hayden, Clarence King, John Wesley Powell, and George Wheeler mapped Western territories and documented their natural resources, including their flora. All of this work traced back, directly or indirectly, to the Lewis and Clark expedition. Their journey had demonstrated that scientific exploration of the West was possible, that the risks could be managed, that valuable knowledge could be gained. They had provided a model for how expeditions should be organized, what kind of training observers needed, what equipment and supplies were necessary for collecting and preserving specimens in the field. The expedition's influence extended to botanical institutions as well. The American Philosophical Society, which had received and curated the Lewis and Clark collections, became a model for how scientific societies could support exploration and research. The success of the expedition encouraged the society to sponsor other ventures, to provide financial support and scientific guidance to explorers heading into unknown territories. The specimens themselves, carefully preserved in the society's collections, became reference materials for generations of botanists. When questions arose about the identity of a plant, about its distribution, about when it had first been described, botanists could consult the Lewis and Clark herbarium specimens. These pressed plants, now nearly 2 centuries old, remained scientifically valuable, physical evidence of what had grown where at a specific moment in time. Some of Lewis's specimens have been studied using modern analytical techniques that he could never have imagined. DNA analysis of historic herbarium specimens can reveal genetic relationships between populations, showing how species have changed over time, how they have responded to environmental pressures, how they are related to other species. The plants Lewis collected have been sampled, with tiny fragments removed for molecular analysis, their genetic codes read and compared with those of plants collected from the same locations in recent years. These comparisons sometimes reveal troubling changes. Genetic diversity has been lost in some populations as habitats have been fragmented and reduced. Stress responses are evident in the DNA of plants growing in degraded environments. The baseline that Lewis provided, showing what genetic variation existed 200 years ago, makes it possible to quantify losses and to prioritize conservation efforts. But molecular analysis has also confirmed Lewis's taxonomic judgments. Plants he recognized as distinct species, based purely on morphological observation, have proven to be genetically distinct as well. His eye, trained by Benjamin Smith Barton and refined through hundreds of field observations, was reliable. The distinctions he noted between similar plants reflected real evolutionary relationships, not just superficial variations. The journals themselves became historical documents of considerable importance, studied not just by botanists but by historians, anthropologists, literary scholars, and environmental scientists. Every entry, every description of a plant or a place or an encounter with native peoples, became evidence about what the American West had looked like at a crucial moment in its history, just before intensive Euro-American settlement transformed its landscapes. Environmental historians use Lewis's observations to understand pre-settlement ecosystems. The prairies he described, where grasses grew taller than a man on horseback, where wildflowers bloomed in dizzying profusion, have largely disappeared, plowed under and converted to agricultural fields. But his descriptions allow researchers to reconstruct what those prairies looked like, what species composition they had, how they functioned ecologically. The buffalo herds that Lewis reported, so vast they took hours to pass, are gone. The animals that depended on those herds have been decimated or have adapted to drastically altered landscapes. But Lewis's records document their former abundance, providing quantitative data about population sizes, distribution patterns, and ecological relationships. This information is invaluable for understanding what has been lost and what restoration efforts might aim to achieve. Lewis noted that Native Americans regularly burned prairies to manage vegetation and improve grazing for buffalo. These observations contributed to a growing recognition that many wild landscapes had actually been shaped by human activity for thousands of years. The prairies were not pristine wilderness but cultural landscapes, maintained through indigenous land management practices. When those practices ceased, the prairies changed, often in ways that reduced their biodiversity and ecological health. Understanding the role of fire in prairie ecosystems became crucial for conservation efforts in the 20th century. Managers of nature reserves learned that simply excluding human activity was not enough to maintain prairie biodiversity. Active management, including prescribed burning that mimicked the fires Native Americans had set, was necessary to prevent woody plants from invading grasslands, to promote the growth of fire-adapted species, to maintain the habitat complexity that supported diverse animal communities. Lewis's observations about fire contributed to this understanding, showing that burning was an ancient practice with ecological effects that shaped the landscapes Euro-American settlers encountered. The natural state of the prairies included human influence, a fact that complicated simple narratives about wilderness preservation. The expedition's plant collections also revealed biogeographic patterns that would become important for understanding evolution and ecology. Why did certain plant genera have representatives in both North America and Asia but not in the regions between? How did plants colonize new territories after glacier retreated at the end of the Ice Age? What factors controlled the distribution of species across landscapes? Asa Gray, one of America's most influential 19th-century botanists, used Lewis's collections and those of other Western explorers to study these questions. Gray recognized that many North American genera had close relatives in Asia, suggesting ancient connections between the continents. He corresponded with Charles Darwin about these biogeographic patterns, and his observations supported Darwin's theory of evolution by showing how species radiated from common ancestors, adapted to different environments, and sometimes went extinct in parts of their former range. The bitterroot that Lewis found in Montana belonged to a genus, Louisia, that was endemic to western North America. Why did this genus occur here and nowhere else? What conditions had allowed it to evolve and persist in these particular mountains? Gray and other botanists puzzled over questions like these, gradually building an understanding of how plant distributions reflected evolutionary history and environmental conditions. That understanding, in turn, influenced how botanists thought about conservation. If a species was endemic to a small region, restricted by its particular environmental requirements, it might be especially vulnerable to habitat loss. If a genus was ancient and had few living relatives, its extinction would represent a greater loss of evolutionary heritage than the disappearance of a species with many close relatives. These considerations became important for setting conservation priorities, for deciding which species and habitats most urgently needed protection. Lewis's collections included several narrow endemics, species that grew only in restricted areas. Documenting these species was important because it revealed that the West's botanical diversity was not uniformly distributed. Some regions, like the Columbia River Gorge, harbored exceptional numbers of endemic species. Others, like vast stretches of sagebrush steppe, had fewer endemics but supported plants that occurred nowhere else in similar abundance. These patterns of rarity and abundance guided later conservation efforts. Areas with many endemic species became priorities for park establishment and habitat protection. The recognition that different regions contributed differently to overall biodiversity influenced how land use decisions were made, though economic interests often overrode ecological considerations. The expedition's documentation of Native American plant uses became increasingly important as ethnobotanists worked to preserve traditional ecological knowledge. Lewis had recorded which plants various tribes used for food, medicine, tools, and ceremonial purposes. As Euro-American settlement disrupted native cultures, much of that knowledge was in danger of being lost. Lewis's journals became one of the few written records of plant uses among tribes who had not developed writing systems. Modern ethnobotanists working with tribal elders have used Lewis's descriptions to help identify plants that were historically important but whose uses had been forgotten as traditional practices declined. The journals provide a baseline for comparison, showing what knowledge existed in the early 19th century and highlighting what has since been preserved or lost. In some cases, Lewis's records have helped revitalize traditional plant harvesting and use, supporting cultural continuity for native communities. The plants themselves have taken on ceremonial and symbolic importance for many tribes. Bitterroot, for example, is honored by several Montana tribes, including the Flathead, as a sacred plant with deep cultural significance. The Lemhi-Shoshone, Sacagawea's people, have used camas roots as a traditional food for generations. These plant-human relationships, briefly documented by Lewis, represent cultural heritage that extends back long before the expedition and continues to the present. But the expansion that Lewis and Clark's expedition helped enable also devastated native peoples and their relationships with traditional plant resources. As tribes were forced onto reservations, often far from their ancestral territories, they lost access to plants they had harvested for generations. Traditional gathering grounds were claimed by settlers, fenced, plowed under, or otherwise made unavailable. The extensive botanical knowledge that had sustained indigenous peoples through millennia had fewer opportunities to be practiced and transmitted. Lewis had documented plant uses without fully recognizing that he was recording the botanical component of cultures that Euro-American expansion would profoundly damage. His journals preserve knowledge that the very civilization he represented would work to suppress. That irony adds poignancy to his ethnobotanical observations, making them valuable but also painful reminders of what colonial expansion cost. In the 20th century, as the conservation movement gained strength in America, Lewis and Clark's botanical work acquired new relevance. The plants they had collected from abundant populations had become rare. The ecosystems they had described as vast and seemingly endless had been reduced to fragments. Their observations provided baselines against which modern conditions could be measured, quantifying the scale of environmental change. When the National Park Service was established in 1916, the mission to preserve landscapes unimpaired for future generations drew partly on the legacy of early explorers like Lewis and Clark, who had documented what American wilderness looked like before intensive development. Parks and wilderness areas were set aside to protect examples of the ecosystems they had described, to preserve at least remnants of the biological diversity they had encountered. Yellowstone National Park, established in 1872, encompassed territory that members of the Lewis and Clark expedition had been among the first non-indigenous people to describe. Later parks in the Rocky Mountains, the Pacific Northwest, and the Great Plains protected landscapes through which the expedition had traveled, landscapes whose plants and animals Lewis had carefully documented. The journals became resources for park interpretation, helping rangers and visitors understand what these places had looked like historically. Lewis's descriptions of grizzly bears, buffalo herds, and pristine rivers provided images of what was being preserved, what values these protected areas represented. His botanical observations showed what plant communities had existed before modern alterations, guiding restoration efforts that aimed to return degraded areas to more natural conditions. Ecological restoration emerged as a discipline in the late 20th century, focused on repairing damaged ecosystems by reintroducing native species, removing invasive ones, and restoring natural processes like fire and flooding. Lewis's plant collections and habitat descriptions became valuable resources for restorationists trying to determine what species belonged in particular locations, what plant communities had existed historically, what conditions were needed to support native biodiversity. Prairie restorations, for example, used Lewis's descriptions of Great Plains vegetation to guide species selection. Which grasses had dominated? What forbs had been abundant? What seasonal patterns of flowering and fruiting had characterized healthy prairies? Lewis's observations, combined with those of other early explorers and settlers, helped answer these questions and inform decisions about what seeds to plant and how to manage restored prairies. Forest restorations in the Pacific Northwest similarly drew on the expedition's observations. Lewis had described the enormous trees, the dense understory vegetation, the abundance of ferns and mosses. These descriptions provided targets for restoration projects in logged or degraded forests, showing what old-growth forests looked like before industrial logging removed most of them. But restoration also revealed how much had been lost and how difficult recovery could be. Some species that Lewis had collected from multiple locations could no longer be found in parts of their former range. Habitat fragmentation had isolated populations, reducing genetic diversity and making it harder for plants to recolonize suitable sites. Invasive species, introduced deliberately or accidentally from other continents, had established themselves and now competed with natives, altering ecosystem function. Climate change added another layer of complexity. Plants that had thrived in particular locations 200 years ago now faced altered temperature and precipitation patterns. Some species were shifting their ranges, moving upward in elevation or northward in latitude as they tracked suitable climatic conditions. The distributions Lewis had documented were not stable but changing, raising difficult questions about what conservation should aim to preserve. If bitterroot historically grew at certain elevations in Montana, should conservation efforts maintain it there even as climate warms and those elevations become less suitable? Or should plants be allowed or encouraged to migrate to new locations where conditions are becoming more favorable? These questions have no easy answers, but addressing them requires the kind of baseline data that Lewis provided, showing where species occurred historically and under what conditions. Seed banks became important conservation tools in the late 20th century, preserving genetic material from wild plant populations so that even if populations declined or went extinct in nature, their genes would be preserved for potential future restoration or breeding programs. Seeds descended from plants Lewis collected, grown in botanical gardens over multiple generations, were deposited in these banks, ensuring that genetic lineages stretching back to the early 19th century would not be lost. The impact of Lewis and Clark's botanical work extended into horticulture as well. Many of the plants they collected became popular ornamentals, cultivated in gardens for their beauty. Clarkia, with its delicate pink flowers, became a garden favorite in England and then spread to American gardens. Louisa species were prized by rock garden enthusiasts for their colorful blooms and their ability to thrive in poor soil with minimal water. These horticultural introductions had both positive and negative effects. On one hand, they raised awareness of Western plants, exposing millions of people to botanical diversity they would never encounter in the wild. On the other hand, some escaped cultivation and became invasive in areas outside their native range, causing ecological problems that Lewis could not have foreseen. The Douglas fir, in particular, became a major forestry species, planted extensively in Europe for timber production. Its fast growth and valuable wood made it economically important, but in some regions where it was introduced, it spread beyond plantations and displaced native vegetation. What began as botanical discovery became, through horticultural and forestry applications, a vector for ecological change on multiple continents. Educational institutions used Lewis's collections and journals as teaching resources. Botany students examined the expedition's pressed plant specimens, learning to identify species and understand plant families. History students read the journals, exploring themes of exploration, colonialism, and environmental change. The expedition became a case study in how scientific knowledge is produced, disseminated, and applied. Museums mounted exhibits featuring expedition artifacts, including plant specimens, journals, and equipment. These exhibits told the story of the journey while also highlighting the botanical discoveries and their lasting significance. Visitors could see pressed plants that Lewis had collected 2 centuries earlier, still recognizable, still scientifically valuable, physical links to a moment when America's western territories were just beginning to be documented by European-descended scientists. Digital humanities projects in the 21st century made the expedition's journals and collections more accessible than ever before. The journals were transcribed, annotated, and published online, freely available to anyone with internet access. Herbarium specimens were photographed and databases created, allowing researchers to examine images of Lewis's plants without traveling to Philadelphia or wherever the physical specimens were housed. These digital resources enabled new kinds of research. Scientists could compare Lewis's observations with modern data, tracking changes in flowering times, distributions, and community composition over 2 centuries. They could correlate Lewis's descriptions of environmental conditions with modern climate records, understanding how temperature and precipitation patterns had shifted. They could use geographic coordinates from Clark's maps to revisit the exact locations where plants had been collected, documenting what grew there now and how it differed from Lewis's time. Some of these studies revealed surprising continuity. In protected areas, especially in mountainous terrain that had not been extensively developed, plant communities still resembled what Lewis had described. The same species dominated. The same associations occurred. Despite 2 centuries of broader environmental change, these pockets of stability remained, testament to the resilience of native ecosystems when protected from intensive human disturbance. Other studies documented dramatic change. Prairie sites that Lewis had described were now farmland, the original vegetation completely replaced by crops. Forest sites he had visited had been logged repeatedly, and while trees had regrown, the structure and composition of the forests had been altered. Riverine habitats had been modified by dams, levees, and water extraction, changing flow patterns and affecting riparian vegetation. These comparisons between past and present, enabled by Lewis's meticulous documentation, made visible the scale of environmental transformation that American expansion had caused. They provided evidence for arguments about conservation needs, about the value of protecting remaining intact ecosystems, about the challenges of restoring degraded ones. Lewis's botanical observations, made without any intention of supporting future conservation efforts, had become essential data for that work. The expedition's legacy also included the many scientists and explorers it inspired. Reading accounts of the journey, young people developed interests in botany, in exploration, in understanding the natural world. Some went on to become botanists themselves, carrying forward the work of documenting and studying plant diversity. Others became conservationists, working to protect the landscapes and species that Lewis had been among the first to describe. The expedition represented a particular vision of exploration, one that combined adventure with science, that valued careful observation and documentation alongside physical courage and endurance. That vision resonated across generations, providing a model for how scientific fieldwork could be conducted even in challenging circumstances. Lewis's example showed that science was not just something done in laboratories and libraries but also out in the world, where weather and wildlife and the unpredictability of travel complicated every observation. This field-oriented approach to botany remained important as the discipline developed. While herbarium work and laboratory studies became increasingly sophisticated, botanists recognized that understanding plants required seeing them in their native habitats, observing how they responded to their environments, noting what grew with them and what conditions they seemed to prefer. Lewis had demonstrated that approach, and subsequent generations of field botanists followed his example. Some modern botanists have literally followed in Lewis's footsteps, retracing the expedition's route and collecting plants from the same locations Lewis visited. These reenactments serve multiple purposes. They honor the historic expedition, educating the public about its achievements. They provide opportunities for comparative studies, showing how vegetation has changed over 2 centuries. And they remind contemporary scientists of the challenges their predecessors faced, the difficulty of conducting fieldwork without modern equipment, transportation, and communication. Traveling the Lewis and Clark Trail now, one encounters developed landscapes interspersed with protected areas. Highways follow the Missouri and Columbia rivers. Cities occupy sites where the expedition camped. Agricultural lands cover much of what were once prairies and sagebrush steppe. But parks and wilderness areas preserve fragments of what Lewis saw, places where one can still find bitterroot blooming, still hear rivers flowing wild, still see forests of old-growth Douglas fir. In these places, the expedition feels present, a ghostly companion along trails that may follow routes the Corps walked. The plants are descendants of the plants Lewis collected, carrying genes that were present when he knelt to examine them. The mountains and rivers, though scarred and altered in many places, retain shapes and patterns that Clark mapped. The connection between past and present seems tangible, a thread linking 2 centuries. That sense of connection drives much of the continued interest in the expedition. The story is compelling not just because it was an adventure but because it represents a moment when much of the continent remained unknown to science, when discoveries waited around every bend in the river, when simply observing and recording could contribute genuinely new knowledge to human understanding. We live now in a world where such opportunities seem rarer. The planet has been extensively mapped and explored. Most ecosystems have been studied, most species catalogued. But the expedition's legacy reminds us that there is always more to learn, that careful observation still reveals surprises, that relationships between organisms and environments remain incompletely understood. Climate change is reshaping those relationships, forcing plants and animals to adapt or migrate or face extinction. Understanding how species respond requires baseline data showing where they occurred historically, what conditions they experienced, how abundant they were. Lewis's observations, made when climate was in a different state than today, provide crucial information for predicting and managing responses to current environmental changes. His descriptions of which plants grew together, which occurred in particular soil types or at specific elevations, amount to an ecological snapshot of Western North America in the early 19th century. That snapshot becomes a reference point, a before picture against which modern conditions can be compared. The comparison reveals not just that change has occurred but its magnitude, its direction, its ecological consequences. Some changes were probably inevitable. Human populations were growing, technologies were advancing, demands on natural resources were intensifying. The wilderness Lewis explored was always going to be transformed by settlement and development. But understanding what was lost in that transformation matters for deciding what should be preserved, what might be restored, what we owe to future generations. Lewis himself died young, his potential unfulfilled, his botanical work incomplete. But the plants he collected survived him, remained useful and valued long after his death. They became his legacy in ways he could not have anticipated, contributions to knowledge that outlasted the man who made them. That legacy continues to grow. Every time a researcher examines one of Lewis's specimens, every time a student reads his journal entries, every time a conservation project uses his observations to guide restoration, his work gains new relevance. The botanical exploration he conducted 2 centuries ago still matters, still informs decisions, still inspires wonder. The plants themselves, growing in their native habitats or cultivated in gardens, carry forward genetic lineages that connect the present to the deep past. A bitterroot blooming in Montana today descends from bitterroots that lived when Lewis passed through. Its genes remember conditions that no longer exist, encode adaptation shaped by environments that have changed. It is both itself and a link to history, both a living organism and a relic of earlier times. In botanical gardens around the world, plants descended from Lewis's collections grow under the care of horticulturists who may not know their provenance. A Clark ear in an English garden, a Douglas fir in a German forest, a bitterroot in a California rock garden. They are, unknowingly, parts of an expedition that spanned a continent 200 years ago, their presence in those distant places a consequence of one man's careful observations and collections. The circle of influence spreads outward from Lewis's botanical work like ripples from a stone dropped in water. His collections influenced Barton and Persh and Lambert. Their publications influenced Gray and Nuttall and Douglas. Those botanists' work shaped American science and horticulture. Generations of students learned from specimens they collected. The impacts multiply and ramify until they touch millions of people who have never heard of the Lewis and Clark expedition but whose lives have been enriched by plants it brought to scientific attention. This is how knowledge accumulates, how science progresses. Individual observations, carefully made and recorded, become parts of larger patterns. Those patterns reveal principles that can be applied beyond the specific instances that generated them. And the principles, once understood, enable prediction and action, allow us to shape our interactions with the natural world more wisely than we could through intuition alone. Lewis's botanical observations, made one plant at a time over the course of more than 2 years, eventually contributed to ecology's emergence as a scientific discipline. They showed how plants were distributed across landscapes, how they related to environmental gradients, how they associated with each other and with the animals that fed on them or dispersed their seeds. The expedition documented not just species but ecosystems, not just individual organisms but the communities they formed. That ecological perspective, implicit in Lewis's observations even though the word ecology had not yet been coined, would become central to biology. Understanding that organisms existed not in isolation but in webs of relationship transformed how scientists thought about nature. It transformed how managers thought about conservation, how policymakers thought about land use, how citizens thought about their connections to the living world. The expedition's plant collections became threads in that conceptual web, connecting species to places, places to environmental conditions, conditions to biological processes. Each thread was factual, based on careful observation. But woven together, they created understanding that transcended individual facts, that revealed patterns and principles with broad applicability. This is the deepest legacy of Lewis and Clark's botanical work. Not just the species they discovered or the herbarium specimens they preserved, valuable as those are, but the demonstration that careful observation, systematic collection, and thoughtful documentation could generate knowledge with lasting value. That science was a way of seeing the world that enhanced appreciation while enabling wise use. That exploration, properly conducted, was not merely adventure but inquiry, not just personal accomplishment but contribution to collective human understanding. In our time, when so much seems known, when information overwhelms and mystery seems scarce, the expedition reminds us that discovery is still possible. Not necessarily the discovery of completely unknown species, though that still happens, but the discovery of relationships, of patterns, of how organisms respond to changing conditions, of what ecological communities need to persist in a world increasingly shaped by human activity. Modern botanists following Lewis's example travel to remote locations, document what grows there, collect specimens that expand our knowledge of plant distributions and genetics. They may not face grizzly bears or navigate uncharted rivers, but they confront their own challenges, from obtaining research permits to funding expeditions to ensuring their collections are properly preserved for future study. The fundamental work of botanical exploration continues, building on foundations that Lewis and others established. And when those modern botanists compare their findings with historic records, they sometimes discover Lewis's observations in databases or herbarium catalogues. A plant he collected from a particular location can be relocated, collected again, compared to assess how it has changed over 2 centuries. Or perhaps it cannot be relocated, and its absence becomes evidence of local extinction, habitat loss, environmental change. Either way, Lewis's documentation matters, provides information essential for understanding what has happened and what should be done. This is why historical botanical collections are not just artifacts but active research resources. The pressed plants from the Lewis and Clark expedition, brittle and faded after 200 years, still have scientific value. They answer questions Lewis never imagined anyone would ask, using techniques he could not have conceived. They serve purposes beyond those for which they were collected, demonstrating how knowledge creation often exceeds the intentions of its creators. Lewis wanted to document the plants of the West for Thomas Jefferson, for American science, for the practical purpose of assessing resources. He succeeded in those aims. But his collections have also supported evolutionary studies, ecological research, conservation planning, climate change analyses, and dozens of other purposes that would have been unintelligible to him. His work proved more valuable than he knew, more enduring than he probably hoped. That endurance reflects several things. The care with which specimens were collected and preserved. The detail with which observations were recorded. The accessibility of the collections and journals to subsequent researchers. And the ongoing relevance of the fundamental questions Lewis was trying to answer. Where do plants grow? What do they look like? How do they relate to their environments? These questions remain central to botany 2 centuries later, even as methods for answering them have become vastly more sophisticated. The expedition bridged a historical moment, the transition from a largely unexplored continent to one intensively studied and developed. Lewis's observations documented conditions that would soon change dramatically. Within his lifetime, the first permanent American settlements were being established in territories he explored. Within a generation, those settlements had grown into towns. Within a century, much of the West had been transformed by mining, logging, agriculture, and urbanization. That transformation could be quantified and understood partly because Lewis had documented what existed before it happened. The baseline he provided made it possible to measure change, to understand its scope and its impacts. Without that baseline, we would know that ecosystems had been altered but not how much, not what had been lost, not what restoration might realistically accomplish. This function of historical data, providing baselines against which to assess change, has become increasingly important as environmental problems accelerate. Biodiversity loss, climate change, ecosystem degradation. These challenges require understanding not just current conditions but trajectories of change, directions, and rates that can only be determined by comparing present to past. Historical records like Lewis's journals and specimens enable those comparisons, turn anecdotes about environmental decline into quantified assessments that can inform policy and management. The expedition's botanical legacy thus extends from 19th century taxonomy to 21st century conservation, from pressed flowers in Philadelphia to DNA analyses in modern laboratories, from Jefferson's vision of national expansion to contemporary efforts to preserve what remains of wild America. It connects eras and disciplines, illuminating both continuities and changes in how we relate to the natural world. As we close this journey through the core of Discovery's botanical achievements and their lasting impact, we can reflect on what makes this story compelling across 2 centuries. It is partly the adventure, the epic journey through unmapped territory. Partly the scientific contribution, the documentation of plants unknown to Western science. Partly the human drama, the personalities and relationships of the expedition members. But perhaps most fundamentally, it is the sense of encounter, of people meeting landscape and organisms for the first time with open eyes and careful attention. That quality of attention, the willingness to stop and observe and record even when exhausted or endangered, represents a particular way of being in the world. It values knowledge for its own sake while also recognizing its practical applications. It combines wonder and analysis, aesthetic appreciation, and scientific rigor. Lewis knelt in dirt beside mountain streams to examine flowers. He pressed plants between sheets of paper by candlelight after days of hard travel. He recorded descriptions with ink that froze in winter and faded in summer sun. He did this not because it was easy but because it mattered, because documentation was part of the expedition's mission, because understanding the West required knowing what grew there. That dedication produced knowledge that has proven remarkably durable and useful. The plants Lewis collected, the observations he recorded, the maps Clark drew, have served purposes their creators never imagined, answering questions that hadn't been formulated, supporting sciences that didn't yet exist. The botanical work of the Lewis and Clark expedition demonstrates how investment in basic research and exploration generates returns that compound over time, accruing value as contexts change and new applications emerge. In our modern world, that lesson remains relevant. We need people who pay careful attention to the natural world, who document what they find, who preserve specimens and data for future use. We need expeditions, though they may be to molecular or genomic or computational frontiers rather than geographic ones. We need the spirit that animated Lewis and Clark, the sense that understanding the world is worthwhile even when practical applications are not immediately obvious. The plants they collected bloom still, in mountains and prairies and coastal forests. In herbarium collections, pressed and preserved. In botanical gardens, cultivated and cherished. In databases, documented and accessible. They are Lewis's lasting legacy, green threads connecting past to present, evidence that one person's careful work can ripple forward through centuries, touching lives and shaping knowledge in ways no single mind could predict or control. As you drift toward sleep, let your mind wander through mountain meadows filled with bitterroot and blue flax. Picture Lewis kneeling to examine a flower, his journal open beside him, his hand steady as he draws what he sees. Imagine Sacagawea gathering roots, teaching the expedition which plants sustained life. See Clark at his portable desk, mapping rivers and mountains, placing each botanical discovery in geographic context. They are all there still, in journals and specimens, in genetic sequences and restoration projects, in gardens where their plants grow far from the wildlands where they were found. The expedition continues in those traces, the journey never quite complete, always offering new insights to those who look with care and curiosity. Thank you for joining me on this exploration of how a military expedition through the American West became one of the most important botanical surveys in history. If this story resonated with you, please like, subscribe, and share your thoughts in the comments. It helps these stories reach others who share your sense of wonder. Until next time, rest well in the knowledge that careful observation, patiently practiced, reveals worlds within worlds. That attention to detail matters, that documentation endures, that one person's curiosity can open doorways through which generations will pass. And that somewhere, right now, a bitterroot blooms pink against grey stone, carrying forward a story that began more than 2 centuries ago and continues still. Good night, fellow travelers. May your dreams be filled with discovery,